All right, so in this video, we're going to look at the work of some European astronomers during the scientific revolution. So we're going to hit most of the big names, most of the big astronomers that are the most famous. We'll maybe throw in a little bit of work of some lesser known astronomers. But basically what we're going to do here is kind of trace the growth of astronomy as a science and see how each one of these astronomers is going to kind of pick apart that Ptolemaic model. Now, one question we normally ask at the beginning of all of this is, why astronomy? Like, why is astronomy the science that sparks the scientific revolution? So, I don't think there's a clear answer to this, but here's my thought about why astronomy is the thing that sparks this. Astronomy is a science that doesn't need a lot of fancy equipment or lots of education. That's not to say that astronomers don't have those things, and definitely equipment and education is going to make astronomy easier. But really, all you need for astronomy is, a book to write things down, a book to write notes, and a clear sky. Really, as long as you have those things, you can be an astronomer. Having a telescope or having the math required to be like an astrophysicist isn't necessarily required. You can be an astronomer with just, with your eyes, just watching the night sky. So this was something that lots of people could do. And I think that there were enough amateur astronomers that these ideas kind of took off and people were interested in what astronomers had to say. Now, the first big astronomer that we have to mention here is Nicholas Copernicus. So, Nicholas Copernicus is a Polish astronomer, although he was famous for being lots of other stuff too. So he was actually more like one of those Renaissance men. He was a polymath. He was good at lots of things. So it's kind of a shame that he's only remembered as an astronomer because he was just like Da Vinci in what he was able to be good at. Now, we don't normally think of Copernicus as being a Renaissance thinker, but he was doing his work mostly in the time that we would recognize as the Renaissance. So he's more a contemporary of Da Vinci than he is a contemporary of someone like Galileo or Newton, who we're going to lump in with him later. So Copernicus is very much a Renaissance thinker more than he is a scientific revolutionary thinker, but we've got to start with Copernicus. So here's what Copernicus noted. Copernicus noted, among other people, he's just the most famous of them, that the night sky did not follow the plans the Ptolemaic model set out. So he noted, like, he was writing this down. He's like, this doesn't make sense. The stars should be moving here, the planet should be moving here, yet they don't do that. And he, I guess, hypothesized that the reason for this was a heliocentric model, one in which the sun is in the middle. And this model now bears his name. This is now called the Copernican Model. Now, keep in mind that he's doing this right at the same time as the Protestant Reformation is really getting going. So Copernicus was really scared of coming out against the church in this period of religious instability. And even guys like Luther agreed with the church that this kind of publication would be heresy. Like, Luther and the Catholics agreed that disrupting anything about how the solar system or the universe was put forward, that was wrong. We can't change that. So Luther agreed with the church on that. So Copernicus kept all of this secret. Copernicus kept all of his stuff secret, and the legend is that his friends published it for him and showed him a copy on his deathbed. And to continue the legend, apparently Copernicus was kind of passing in and out of consciousnness. He was kind of lucid, and then he was kind of he then lost his stream of consciousness, and then his friends gave him the book, and he kind of became himself again and thumbed through the book and then died peacefully. That's probably a legend, but it's a nice story. So here's one nail in the coffin for the Ptolemaic model, and it's a big nail. The sun is actually in the center of the model, not the Earth. Copernicus actually did his best to try to fit the Ptolemaic model into the heliocentric model. But try as he might, it just didn't fit. He tried to force it, and it just didn't work. There are a couple of other guys. We're not going to go too deeply into these two guys, although they are very interesting characters. And if you ever get a chance to research these guys on your own, I would really recommend it, because these are fascinating people. But we're not going to spend much time on them. Nope. Tycho Brahe and Johannes Kepler. Do yourself a favor and read about Tycho Brahe. He is a really interesting person. But these guys, so Brahe and Kepler, were colleagues. Brahe was kind of like the senior colleague, maybe the mentor. Kepler was his student. What they discovered was that planets moved in elliptical orbits, not circular orbits. And I think that Kepler has a set of laws of planetary motion named after him, because he and Brahe discovered that planets move in elliptical orbits. So instead of circles, they move in ellipses. So forgive my artistic ability, but I think you get the idea. Circles versus ellipses. Another nail in the coffin. The next guy is really important. His name is Galileo Galilee. Decidedly after the Renaissance. This is maybe the first guy who is purely a scientific revolution guy. Galileo is famous for, among other things, being the first astronomer to make scientific discoveries with a telescope. So the telescope was kind of perfected by Galileo. And by doing so, he's going to contradict a lot about the Ptolemaic model. So, for instance, like if you were to just look at the moon, you will see it is made of rocks, just like the kind of rocks you find on Earth. It's not perfect. It looks just like Earth. It's made of rocks. You'll also see a bunch of new planets. And some of these planets we already knew have their own moons. So there's a lot more than simply 10 planets. There are hundreds of planets. Now there are maybe possibly hundreds There's probably at least 150 moons of Jupiter and Saturn alone. So Galileo was a celebrity. So Galileo was very famous. And he was invited by many monarchs to come visit and give lectures. So he was kind of like a celebrity scientist, kind of like your Bill Nyes or your Neil deGrasse Tysons. He was a very famous scientist. He was a celebrity. Here's where he gets into trouble, though. His most famous work, it's called A Dialogue on the Two Chief World Systems. Which was published in 1632, got him in trouble. Originally, the Pope gave him permission to publish this. But once it was published, the Pope thought it made fun of him. It didn't, but the Pope and Galileo were maybe not friends, but they were acquaintances, they were allies. And when the Pope gave Galileo permission to write this, and it puts the church in a negative light, the Pope thought it was making fun of him personally. And so the Pope had the authorities arrest Galileo. And he's put on trial. And Galileo recants. So he gives in. Galileo recants, says he's wrong, says Copernicus is wrong, and Galileo is set free. Sort of. He's put under house arrest. The alternative, of course, would be death. So Galileo saves his own life. Now, the legend is that as he's leaving the courtroom, he says, and I'm probably going to mispronounce this, "Ieper si muove," which in Italian means, "and yet it still moves," meaning the earth. Basically, Galileo is saying, regardless of what you do to me here, the results of this trial are meaningless. The earth still moves around the sun. You can make me say whatever you want me to say. The earth still moves. Now, this is the legend. Of course, we don't know if Galileo actually said this. This is probably said after the fact to make Galileo look better for having recanted. He spent the rest of his life doing scientific research, but on less controversial stuff. like inertia and momentum, which is still important stuff, but not nearly the groundbreaking stuff that he was doing with his telescope. The last guy that we're going to take a little bit of time to talk about is one of the most important figures in European history, and this is Isaac Newton. Find a pen that works. So Isaac Newton is maybe the most important figure in the scientific revolution. He is also one of the most important figures in European history. So 1642 to 1727. Now, before we get into his science stuff, there are some other parts of Newton's life that I want to talk about because they're just so interesting and weird that they absolutely bear some discussion. So, first, Isaac Newton invented calculus while on a break from school. There was an outbreak of plague at Oxford College, and he was sent home in 1666. And he invented calculus while he was on a break to do some math problems. Now, there is some debate over who actually invented calculus, because there's this other guy, Leibniz, is also credited, but he's not nearly as interesting as Newton, so I'm going to give Newton the credit for calculus. Later on in his life, he is given an honorary title. So he's given this honorary title as Warden of the Royal Mint. So this is meant to be, so this is much later in his life. So we haven't really gotten into the reason why he's given this title, but I want to cover this stuff first before we do the science stuff. So this is much later in his life. So this is an honorary title. You don't actually do anything at the Royal Mint. It is just an honorary title. But Newton took this job very, very seriously. I guess technically the job of the Warden of the Royal Mint is to find and arrest counterfeiters. Like, that's the job. But there's like a whole staff and an office of people that do that. This guy is just like the honorary head of the office. But Newton took this job so seriously, he invented new methods of detection of counterfeits, of counterfeit money. And he actually went undercover to arrest counterfeiters. Newton is a very interesting person. Now, with all of that being said, Newton is probably one of history's biggest jerks. most people in their accounts of Newton mention how disagreeable a person he was. So he is absolutely one of history's biggest jerks. But that also doesn't take away from his contributions to science. So after what happened to Galileo, most of science, so how about we say scientific thought moves north, mostly to England and France, and the Netherlands. Here, scientists could have a little more freedom. So they could have the freedom to work in England or France or the Netherlands. They'd have more freedom to work without the church disrupting them. Now, Newton's main contribution to science besides, inventing calculus, are his 3 laws of motion. And here's why these matter so much to us in this course. These 3 laws of motion, which we're not going to go into, we're going to talk about why they're important. The 3 laws of motion are so important because they are, 1, easy to understand, and apply universally. They apply to planets just as much as they apply to pieces of dust. They apply to everything in the same way. So, the reason that Newton is so important to us is that other philosophers are going to try to recreate the ease and universality of Newton's laws. But they're going to try to apply them to society. So we're going to try to take the idea of Newton's laws, really easy to understand laws that apply to everyone the same way, that explain how society functions. We're going to try to apply them to society. And that is what is going to be one of the sparks of the Enlightenment. Attempting to explain society in the same succinct and easy to understand way that Newton just explained how everything in the universe moves. One more thing about Newton that bears a little bit of discussion, although we're not going to delve really deep into this, is that Newton was also really into astrology and alchemy. Alchemy is basically the idea that you can turn anything into anything else. When scientists learn about chemistry and chemical reactions and how you can turn some things into something else using a chemical reaction, early scientists are going to get it into their head that you can turn anything into anything else because you can turn some things into something else through chemistry. And so basically what they're trying to find is the method to turn something into gold. That's what they want to find. Newton actually wrote more about alchemy than he did anything else. He was crazy about alchemy, and he wanted to find this thing that would turn metal into gold, the quote-unquote philosopher's stone. He was also really into astrology and interpreting the Bible to tell the future. He was really into using the Bible as a means to tell the future. He tried to figure out the end of the world. He tried to date the end of the world. And depending on how you interpret what he came up with, he either said the world would end in the year 2016 or maybe the year 2060, depending on how you interpret what he said. He also, and he kept this really, really well hidden because this could have ruined him, he had a lot of weird ideas about Christianity. Specifically, the idea that he didn't believe in the Trinity. Capital T, Trinity. I mean, if you haven't noticed, I could go on and on about Isaac Newton because he's just such a weird, interesting character. But I think we'll stop there. We'll talk more about religion and science in our last video on this series. But this kind of takes us through most of the big astronomical advances that really put the church back on their heels when it comes to explaining the natural world. So in our next video, we're going to look at another branch of science. We're going to look at medicine. And we're also going to look at the role of women in science because women actually now get to have a role in this. So until then, this is Mr. Nissen signing off.